Right, so since people had a little bit of trouble yesterday with 3.7, we're gonna look at it a second time. Okay? I know I just said it, but just as a reminder, so it's in the video. On Thursday, you will have a take-home test due Friday at 7:45. So let's take a look at just some reminders first. This part you don't need to write down, but when they give us a problem, okay, just like in the homework, just like some of the practice ones we're going to do today, they generally ask you to do three things. Okay, graph it, so that's where you draw the V shape. Compare it, so did it shift left, did it shift right? And then the last thing, describe the domain and range. So let's go back and look at those three things again. So those are the three things they ask you to do. Graph it, compare it, and then describe the domain and range. Okay, we're going to look at each part individually before we do any examples. And I don't think there's, no. All right, so first thing you have to do is graph it. Does anyone remember what our steps were to graph it? What's the first thing you had to do to get the first x value? Yep?
Set what is inside the absolute value by is equal to 0.
Yeah, she's looking at the notes. That's perfect. So you set up your table. Okay, we're going to make a table with x's and y's in it. And Ellie just told us the first step. You don't have to write this down. You already wrote this yesterday. So just watch this part. Set what is inside the absolute value bar is equal to 0 and solve. Okay? That number is going to be your middle x value. Now, is that enough x values? Do we just need one, or do we need more? We need more, right? You can't draw a V shape with one. You gotta get more. So we need additional x values. Once we have the one that's in the middle, how do you get other ones? What did we say we do? Get the one that's in the middle, and then, Nicole? Two smaller, two bigger. Exactly. Two smaller and two bigger. So you pick two that are smaller, two that are bigger. Now, how many would we have in total at this point for x values? We'd have 5, but we're missing something. We'd have all those. What are we missing? We're missing the what? We're missing all the y values. That's the next step. We're going to calculate the y values.
What does that mean, calculate the corresponding y values using the absolute value function that's given? So basically, what do you have to do? What are you doing with the x values? What do you have to do to get your y? What do you have to do with those x's to get your y?
You're going to do it 5 times. Yep. Plug them in. Exactly. So you're going to plug in each one of those x values one at a time, do the arithmetic out, and write down all your y's.
Mr. Hager, he's a mathematician, so he said you can plug them in 5 times. Me not being a mathematician, I only say plug them in 3 times. Why do I say that? When I do it, I only do it 3 times. What's the reason for that? Anybody remember yesterday, Yusuf?
Because it's the same.
Exactly. The middle 2 match up and the outside 2 match up. So once you get once you do the first 3, that 4th one is going to be the same as the second one. That 5th one is going to be the same as the first one.
As long as you write them in numerical order. If you mess up your order and you write like -3, 0, 2, 1, and you put them out of order and you match them up out of order, that's not going to work. So make sure you list them in numerical order if you're going to do it. All right, so that's step 1 for the graphing. Step 2 is to compare it. So this is where we say, all right, it shifted up, it shifted down, left, right. We have to describe what happened.
And guys, this is where you're going to fill. This is where you're going to fill it. You're going to see when we talk about it. Just like last week, when we gave you like the function of like f of x minus 2, right? And we gave you that chart, and we said, if it looked like this, then it was this type of transformation, and you could describe it like this. We can do the same thing when we're doing absolute value functions. All right? So this is when you want to fill out. This is when you want to fill out your chart.
So you have 6 lines on your chart because there's basically 6 different types of transformations we studied. The first one looks like this. It's either x plus a number or x minus a
So
number.
my suggestion, guys, might be you might want to put them like on top of each other. X plus a number on the top of the box, then the bottom of the box.
Now, this is inside the bars. Okay? Inside the bars. Now, what operation am I doing right here?
Addition.
Addition. What about here?
Subtraction.
Subtraction. Anytime that you add or subtract inside the bars, the type of transformation is a horizontal shift. Okay, horizontal shift. So under type of transformation, put horizontal shift. Now, there's one more box there that says written, right? When we're comparing it, making a comparison. Part of what you're going to put there involves horizontal shift. If it's a positive number, shift left, and then the number that you see inside. Okay? Whatever this number is. If that number I just underlined was a 2, you would say shift left 2. If it was a 5, you would write shift left 5. If it was a 7, you'd put shift left 7 units. Okay, whatever the number is. So positive is left.
So negative would be right.
Negative, like here, negative would be to the right. All right, so with that, if it's a negative, inside the bars, you would say shift right blank units. Whatever the number is. Shift. Don't say shift right negative 2 units. All right? That sounds kind of weird. Like Mr. Roy said, even if you walk backwards, it's not negative units. You're just walking in a different direction. Okay? But you're still walking 2 units this way or 2 units this way. All right? Left and right takes care of whether it's positive or negative. So negative is right, positive left. Okay, another transformation. Okay, number 2. This is still inside the bars, but it's not addition anymore. What operation is it now? It's multiplication. Multiplication is a different transformation. It's not a shift. Still begins with an S. Does anyone remember what that is? Yeah?
Stretch.
Stretch. So whenever you multiply, it's a stretch. Now, you're inside the bars. Whenever you're inside, look at the pattern here. Horizontal. When you're inside,
Horizontal.
still horizontal. Stuff that's inside the bars is always horizontal, but it's multiplication, so it's a stretch. Okay, so under number 2, type of transformation, you want to put horizontal stretch. And this is how you would write it. This part always stays the same that I underlined. Horizontal stretch by a factor of 1 over the number. That part changes. If the number is 3, horizontal stretch by a factor of 1 over 3. If it was 6, horizontal stretch by a factor of 1 over 6. Okay, it's whatever the number is in the problem. And if the number was a fraction, then I would use my calculator to figure it out. Let's pretend the number was 1/2. Right? Horizontal stretch by a factor of 1 divided by 1/2. I would just use my calculator and figure out what 1 divided by 1/2 is. I just have to type it in because it's that one's a little tricky because of the fraction. All right, but it's always horizontal stretch by a factor of 1 over, and then write your number. And use your calculator if you need to. So there's one more type of transformation. We did shifts, we did stretch, and what's the last one?
Vertical.
So we're going to get to vertical in a second, but there's one more under horizontal. Reflection. Does anybody remember what symbol you usually see when there's a reflection? A negative. So you're going to see a negative inside. Remember, inside the bars is your horizontal. So right there, negative. You know what? I just want to put, let me just, before you write that, let me just double check. Yeah, just write it like this. Negative and then an X. So it should look just like that. Yep. That's what a reflection looks like. Yes?
And do you have a pencil anymore?
Pencil? Yeah.
So negative x is like both values.
Yep, so negative X, inside the bars, because it's inside, it means it's horizontal. And when you put a negative, it's a reflection. So inside the bars is always horizontal. Could be a shift, could be a stretch, could be a reflection. In this case, negative means reflection. So a horizontal reflection would look like this. It's like a mirror image flipping it left to right. Like imagine folding a piece of paper vertically right on that line, and it would land right on top on the other side. That's a horizontal mirror image. All right, and now for this one, let me fix this. You would just say, I would just say, just write this part. Reflected over the y-axis. Okay, reflected over the y-axis. If there was a number with the x, well, that's what we talked about. I'll come right back down. But that's what we talked about right here. So that's different. If you have a number with the x, we'll do one like that. But if you have just a negative with the x, that's a reflection over the y-axis. All right, so we did the 3 things that are inside. Horizontal shift, horizontal stretch, horizontal reflection. Horizontal, horizontal, horizontal. Now we're going to do stuff outside. So it's not going to be horizontal anymore. It's going to be shift, stretch, and reflection, but they're all going to be
Vertical.
They're all going to be the verticals. All right, so let's look at this one. So notice it's plus or minus again. Wait a minute, hold on. That's the last one you do. So vertical shift. Let's go to, I'm going to renumber these for you.
Repetition.
There we go. That's number 4.
And the other one's number 5.
Yeah, I'll renumber. So number 4 is when you have a number times x. A number times x. So I'm looking at it. I'm like, okay, I see number on the outside. The fact that it's outside the bars tells me vertical right away. Now I say, all right, is it a negative? Is it a number? Or is it addition or subtraction? It's a number. Whenever you multiply by a number, that's a stretch. And I did it on the outside, so that means it's vertical. So that's a vertical stretch. And this one, you would write vertical stretch by a factor of, and then you put the number. So if it was like a 2 on the outside, it would be vertical stretch by a factor of 2. All right, so vertical stretch by a factor of, and then you put the number. Now I'm going to have to scroll back up to your number 5.
I screwed up the mistake, I'm sorry.
Okay, we're good. No problem. I got it.
Adjusting.
All right. Does everybody have that one? All right, so now the next one. We did the stretch. What else can you do? Not the shift yet, but there's the reflection. So that's going to be number 5. All right, and the way you would see that one, let's just write it like this. So we already took care of when you have a number in front of x. Right? That's that one. When you have just a negative, just like that, we say, okay, just a negative. What does that mean? It means a reflection. Where is it? It's outside the bars. Anything outside the bars is always which way? Always vertical. Sorry, always vertical. So it's outside the bars, it's vertical. It's just a negative. That means it's a reflection.
Mr. Hager, could you have a number outside that's negative?
We treat it as a separate transformation.
Okay.
Yep. 2 separate.
Okay.
Yeah. So what Mr. Roy is saying is if you had something like this outside, that's actually 2 transformations at the same time. And if you're thinking, huh, how's it 2? 1, 2. 2 separate things. A lot of people see the negative and they see the 3 and they're like, oh, it's just one thing. Nope. That's 2 things at the same time.
So Mr. Hager, you might have to tweak my description, my comparison a little bit. I did it as if it was two transformations.
All right, so now, when you're comparing it, all you're going to write, just like I did before,
Yeah, we don't need that.
when you have a negative on the outside, all it does is reflect over the x-axis.
But if you have a number and a negative, then that's how the way it's written there, that's how you write it.
Yeah, that would be a whole separate transformation. When we number them, it would be its own separate number.
So the negative and the number they're separate from each other, not connected.
Yep.
As we think of this stuff.
So vertical, that's reflecting over the x-axis. So just as kind of an image, what that would look like. I just drew a triangle, but that's a mirror image vertically. If I took what was on top and flipped it down. Okay, so that's your 5th one. So we've done the vertical stretch. We've done the vertical reflection. What's the one we haven't done for vertical yet? Vertical shift. So let's go back up. So the last one you do is your vertical shift. So that's when you have plus or minus. But look where the plus or minus is. Is it inside or outside the bars?
Outside.
It's outside. So outside the bars means it's vertical. Plus or minus means it's a shift. Put the 2 together, vertical shift. And that's always the very last one we would list. Not every problem is going to have all 6 of these in them. We'll check for all 6, but maybe we'll only find 1 or 2, or maybe 3. I doubt you're going to have any problem. I know you don't have any problem with all 6. All right, so this one, there's 2 directions that you can move. Positive number, like this. X plus a number shifts up.
You guys, on your notes, you can save yourself some space. What I might do is, I might just put, rather than writing for a positive number, I might just write plus, put a little thing, and then write that description. So you don't have to write this whole thing. Just put a plus, and then put shift up, number outside of units. Then you do the same thing for minus. Put minus, put a little colon, and then write what the description is.
So if a plus on the outside, vertical shift up, what do you think a minus on the outside is going to do? Down. So now when we do examples, I want to make sure everybody keeps this chart right in front of them. At least for the first two, you don't even have to flip back and forth. You can just look right at it. All right? And on the take home, which you'll have on Thursday, I would keep this chart out and use it. Yeah, you can use it. Yeah, you can use your notes.
You can go back to math with Hager. You can use pretty much whatever you want on the test on Thursday, except each other. Anything else is fine.
Okay, does everybody have what to do for a positive and what to do for a negative?
Yeah.
All right, and then this one we already did.
Those ones.
We did that. Now we did that. All right, so the very last thing, I think this is probably, the easiest part, because you've already done the sketch, you've already done the comparison. You just have to describe the domain and range, and one of those never even changes. It's always the same thing in every problem. So, domain. That's where you're describing your x values.
You see domain, then you see the little set of parentheses. Just right inside those parentheses to remind yourself that the domain is the x values.
Domain is how far a function goes left and right. Well,
And then range is y.
if you draw a V shape, does the V, like if I put those arrows on the end, does it keep going left and right forever? It never stops. That's why when we describe how far left and right this V shape goes, we say it goes on forever. That's what you're saying right here. It goes on through every number forever.
Always all real numbers.
Now, how about range? When you draw a V shape, does a V shape go up and down forever?
No.
No. A V shape either looks like this, where it has a lowest value and it goes up forever, or I think we did one yesterday, the very last one, it looked like this. It's still a V shape. It's just an upside down V shape. So in that case, look at the arrows. It's going down forever, right? So the whole key is you've got to find this value. And what do you call that? Does anyone remember that?
Where it starts to change direction.
The vertex. So your range is always every point from the vertex and up, or every point from the vertex and down. It's
So
always one of those two.
What would the graph look like to have every number from the vertex up? Which way would the graph open? Which direction? Up or down? To have everything from the vertex up. It would open up, right? Okay, so when it opens up, what letter do I have to describe my range? What letter has to be in it?
Y?
Y, correct. And then that'll be a Y. After that, we need an inequality sign. What inequality sign? Close. Yusuf? Greater than and equal to, and then the lowest number the graph touches on the y-axis.
So here's your graph. I did something like this. That's an example of what
And then it may not always be that number may not always be directly on the y-axis. If it's a horizontal shift, left or right, it's not going to be directly on the y-axis. You just have to see what grid line it's on, look over to your left or right, and see what number that is on the y-axis.
And make sure you copy down the other case. It would look like this. You'd have a point, and the V shape would open down. See,
Wouldn't that be x-axis or would it be still the y-axis?
it's still the range is always the y-axis. So your range here would be everything from this point down, right? Because it's going down. And that's why Mr. Ray put in less than, because when you go down, down is less. It's less than or equal to. And I think for every problem we do, it's always going to line up at a nice number. You're not going to have to look at a graph and guess if it's like 5.2 or, I'm pretty sure they always end up on nice numbers.
Maybe I know they are. The ones we do today, we use whole numbers.
All right, so that's kind of recapping all the stuff from yesterday. All right, now we'll practice examples for probably maybe 25.
I think
30
we get
minutes.
it set up where that we give them one,
Yeah.
and then the next one they can try on their own.
All right, so let's look at this one. All right, they're asking us to do the three things: graph it, compare it, domain and range. So let's start with the graph. Okay, so what do I do? First thing I have to do anytime I make a graph. What?
I know that from what I can see, I know that it'd be a horizontal shift.
Yes, very good. I agree. It is a horizontal shift, 3 units. We'll have to describe which way in a second. That's going to be this part. I mean, you could do that part first, but we'll do the graph first. Yeah.
After 0, middle.
Let's take what's in the middle and do what?
What?
So you said put 0 in the middle, not
Like,
quite.
1 and 1, 2, and
So you're thinking 0 is going to be our middle x value?
I mean, I was supposed to get rid of the bars first. And then
Yep. So you get rid of the bars, but what do you do with what's inside the bars? Look back at your sheet from this day if you need to. Yep. Yes. Take what's inside the bars, set it equal to 0.
Could 3 would be in the middle, right?
The what?
Could 3 be in the middle?
No, 3 is not going to be in the middle. What do we do with that now? Yep.
solve for x.
Solve for x. So when I minus 3 from each side, what number is going to be in the middle? Negative 3. So negative 3 is in the middle. Now what do I do? Pick 2 that are smaller, 2 that are bigger. All right, can you give me 2 that are smaller? Negative 2, negative 1, okay. And 2 that are bigger? Negative. Well, we've got the right values. We just got to work on really what's bigger and smaller. Technically, these are smaller. All right, so negative 4 and negative 5 are smaller. Negative 1 and negative 2 are bigger, but we're good. Now, am I ready to graph? No, I'm missing half my table. So what do I got to do now? Find the y's. How do I do that? Yep.
You would have to do negative 1 plus 3.
Yep. So we're going to take
And
each number.
add it to
And what happens if you do that? What's negative 1 plus 3?
negative 2. 2.
Good morning. Please pardon this interruption.
All right. So now, can you? I think we're in the middle there, Allie. What's negative 1 plus 3?
2.
2. And what's the absolute value of 2?
Negative 2?
2. Absolute value is always positive.
Right, positive, not opposite. Sorry.
Let's do the next one. Oh, you're good. Negative 2. Ryan, what's negative 2 plus 3? Positive 1. And what's the absolute value of positive 1? It's 1. Yep. Okay, let's do one more. Plug in negative 3. How about, yeah, Yusuf?
0.
0. Negative 3 plus 3 is 0. What's the absolute value of 0? 0. Now, as long as you put your numbers in numerical order, you're going to repeat the next 2 values. Just make sure you put those in the right order. Okay. And there's our table. So that's the hard part for the graph. Now, what do I do with all those points? Yeah?
You have to graph them. So, like, you do negative 1, 2.
All right, let me do that one. Negative 1, 2. Got it?
And then you do negative 2, 1.
Negative 2, 1. Okay.
And then you do negative 3, 0.
All right, I got that one.
negative 4, 1,
Negative 4, 1, got it?
and negative 5, 2.
Negative 5, 2, got it. Looks like a nice V shape. If you get something that's not a V shape, you might have made a mistake. But you did make a mistake. Okay, it should always be a V shape. So just draw it best you can. So graph the function. We're good. Next thing is compare it. Now Ellie already told us. What did you say that this was?
Horizontal shift.
It's a horizontal shift. So I'm going to start with that.
And be like positive shift left number of units and negative shift right number of units.
So positive shift, you said positive goes which way?
To the left.
Positive does go to the left, I
And then
agree.
negative goes to the right.
And negative goes to the right. So it's a horizontal shift left. How many units?
3 units.
3, because it's a plus 3. Exactly. Left 3 units. Okay, that's the second part. I think that part's easier than the graphing part. I think it's quicker. All right, so we got that. Last part, describe the domain and range. Well, one of these we don't even need to think about. Yusef? Domain, all real numbers, yep. Did you say all reals?
No, I said all.
Oh, okay. Because you could say all reals.
You could?
Yep,
Oh, awesome.
all real numbers.
Put that down.
All right, range. Look at that V shape. Does it have a low value and go up, or does it have a high point and go down? Yep.
It has a low value and go up.
What is that low value on the y-axis? How low does it go?
It goes to negative 3.
That's the x-axis.
Oh.
So how low?
Y-axis goes to negative, so to 0.
Yeah, it goes as low as 0. What letter do we always use with range? Y. And all my y values in that graph, are they above 0 or are they down below 0?
Above.
They're above. So they're all greater than or equal to 0. Okay. Any questions on that? So that's what we did yesterday. Okay, so that was a horizontal shift. We're not going to be able to do one of every single type because we have 6 of them. But let's try. Let's see. That's another shift. All right. Let's.
Which example?
We'll skip to example 3. Example 2 is very similar. Okay. This example 2. I'm going to skip this one because it's subtraction inside. So it's almost like the last one. This is different. It's outside. So let's do that one. Okay, what's the first thing I have to do here? Exactly, set what's in the middle equal to 0 and solve, but it's already solved, right? There's no other numbers with x on the inside, so what's my middle value? It's just 0.
See, I was right this time.
Yes, you were.
Yeah.
Now, what should I write down next? Still got to put some more stuff in that x column. Yep.
Oh, like above it, you should put -1. Or -2 and -1.
Yep. Do -2, -1. Need a little bit more. 1 and 2. And now, what do I do with all 5 of those? No, well, you only have to do it with 3 of them, and then you're going to see a pattern. Yep. Plug it in. Let's start with -2. What's the absolute value of -2? 2. Take away 2. 0. Let's do another one. -1. What's the absolute value of -1?
1.
1. Take away 2. -1. One more, and then we're going to see the pattern. Plug in 0. What's the absolute value of 0? 0. Take away 2. -2. Now, if you did the next one, the absolute value of 1 is 1. 1 take away 2. You get that value repeated, and then that other value repeated. Okay. Now, what do I do with all those points? Yep.
You graph them.
Graph them. -2, 0. All right, I got it. -1, -1. Okay. 0, -2. So far, so good. Looks like I've got one side of a V shape. 1, -1. Write 1, down 1. 2, 0. Write 2. That's it. Looks perfect. I got a V shape. And I can even tell, looking at the V shape, which way it moved. The point of the V should be at the origin, but it's not. It moved. And that's what we'll describe in the next step.
That's good.
Does that make more sense than yesterday?
Just a little bit.
A little bit?
Yeah.
All right.
It's working for us.
So there's our graph. Now we want to compare it. We did a minus on the outside, minus a number on the outside of the parentheses, outside of the bars. What does that do? When you minus a number on the outside of the bars.
Oh, I know this one.
Vertical what?
I love this.
Yeah?
It'd be vertical shift.
Vertical shift, and now it's minus a number. Minus goes which way?
Down.
Down. That's exactly what you want to put right there. So shift down. Now we have to write how many units?
-2.
How many?
2.
2. We already kind of represented the word negative. We used down. Down means negative, so don't worry about that. How many? 2. Shift down 2, you should put units. All right. What's my domain here?
All real numbers.
All real numbers. It goes left and right forever. And now my range. What's the lowest y value that V shape ever hits? -2 is the lowest. What letter do we always use with range?
Y.
Y. And now, are the y values above or below -2?
Below. Above?
Well, if they were below, it would be down in here.
Yeah, so it's above.
It's above.
So would it be greater than?
Greater than or equal. Yeah, whenever you write the range, you always have the equal under it with an absolute value. Okay. Any question on that one? So we get it there, a table, a graph, compare, domain, and range. Let's finish up with, we're going to do example 6. So we're kind of skipping around. We did 1, we did 3, and now we're going to do 6. Step 1.
Do I know what this
What do I do first? Yep.
You have to do the x values.
Set the x value in the bars equal to 0. And now solve for x. But if you solve for x, what do you get? It's already solved for x, right?
0.
X is already by
That's what I
itself.
was trying to say. I was kind of confused.
Now what?
Then you have to do -2, -1.
-2, -1, and
1.
1 and 2. So the same x values as last time.
Wow.
Okay, now what? Yep,
You have to do the y values, so that means you have to do -2.
plug them in.
This by x, and then -2 minus -2 is.
Careful, no minus here. This is multiplication.
So -2 times -2 is
What's the absolute value of -2?
2.
2 times -2.
-4.
4.
Let's do it again.
Quick maths.
Absolute value of -1.
1.
1 times -2.
-2.
Absolute value of 0.
0.
0 times -2.
0.
0. And now the next ones are going to repeat. Okay, what do I do now? About Yusuf?
What?
What do I do now?
Oh, plot the plot on the graph.
Plot the points. -2, -4, -1, -2. All right, 0, 0. All right, so far I think I'm good. I got one side of a V shape. Right 1, down 2. Looks pretty good.
Oh my God.
Right 2 down 4. Looks good. There's my graph. Now, let's compare it. Let me write it again right here. How many transformations are happening there? 2. Let's start, if you look back at your order, always start with this one. Ignore the negative for now. What's that 2 going to do? It's multiplication on the outside. Yep.
Would it be multiplied by x?
Vertical.
It's a vertical reflection. It's a vertical reflection.
I'm going to erase that negative for now. We'll come back to it.
It's reflection.
What's the? Start with the 2.
It would be
Vertical
vertical stretch.
stretch
Just stretch out.
by what?
If students want to start heading out front, you may do so now. Thank you.
All right, I'll just finish that up. So vertical stretch by a factor of 2 and reflect over, that's vertical x-axis. Because there's a negative and a 2. All right, so tomorrow if we need to, we'll finish up the domain and range.
I think we need to go over that again. Okay, now this is happening.
All right, so homework tonight, I'll give it to you on the way out. Just a few more practice problems. Test is a take-home this week. Friday is a half day.